Hi guys. You needed to go over all of the problems on the worksheets for the angle sizes with your groups, and you should probably compare stuff with other people. Now, what's interesting is I'm going to come in here, and I am going to just make sure that my pen works, and it does. Okay. And I want to go in here, and let's say that we start off with the 60-degree angle. And the most important thing I am interested in is the ratios, the opposite over hypotenuse, adjacent and opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Those are the things that I'm most interested in. So just so you know, I'm going to give you the actual ratios, and then you guys can compare to how well you did with them, and then we'll just kind of take it from there, okay? So if you had, for the first one in here, your opposite over hypotenuse for the 60-degree angle, the generalization for the opposite over the hypotenuse in general, or the closest that you should have had, was 0.8660. Okay, so if on your column that decimal looks pretty close to what I have here, you did a great job. Now, when you did the adjacent over the hypotenuse for your 60-degree reference angle, you all should have known that it came out to be 0.5. And you should have something that was super duper uber close to 0.5. And then finally, the opposite over adjacent was equal to 1.732. So if you had something remotely close to any of these three, for the opposite over hypotenuse, the adjacent over the hypotenuse, and the opposite over the adjacent, you did a great job. And that's for the 60-degree reference angle. So now you want to ask yourself, what does that mean, right? So when we did all of our 60-degree angles, what you all should have noticed is that they're all similar, which means the ratios of the opposite over the hypotenuse for any 60-degree right triangle, for any 60 degree. So if I come over here and I put my 60 degrees in here, the opposite over the hypotenuse, the ratio is always going to be 0.8660. The adjacent side, which is this guy here, over the hypotenuse, is always going to be a half. And then the opposite over the adjacent is going to be 1.732. That works for all 60-degree right triangles. So what does that mean? Okay, let's talk about what that means. All right, and so if I come in over here, I don't know why it won't let me in here. So if I come in over here and I go ahead and start with a right triangle, let's go over here and let's put some values in. So let's say that we want to make this like 10, and then I want to ask you to find A and B, okay? The first thing you want to ask yourself is who am I given in relation to the triangle? And if you look at the 60-degree angle, you'll be like, well, you gave me the opposite side, right? Now you have to decide, who do I want to find first? Do I want to find A or do I want to find B? Who do I want to find? Well, let's say we want to find A. So who is A in relation to the 60 degrees? And you should all say to yourself, what's the adjacent side? So if I'm going to find out what A is equal to, I want to know it's going to involve the opposite and the adjacent. So if I look over here to my three ratios, the opposite and the adjacent is this guy right over here. So when I do my ratio, I'm going to do opposite over adjacent is equal to opposite over adjacent. So opposite over adjacent here, opposite is 10, adjacent is A, and that's going to be equal to this opposite over adjacent, which is 1.732. Now all we have to do, folks, is throw this guy over 1 and then cross multiply. So I get A times 1.732 is equal to 10. So I'm going to come on over here because I have no space. So 1.732A is equal to 10. So A is equal to 10 divided by 1.732. So if I do 10 divided by 1.732, I wind up with 5.774. So this is equal to 5.774. Now to find B on this case, we have, again, we're going to use the opposite, but now I'm asking you to find the hypotenuse. So if I give you the opposite and you're on the hunt for the hypotenuse, which of these three ratios are you going to use? You got it. You're going to use this one right over here. So again, your ratio is going to be opposite over hypotenuse equals opposite over hypotenuse. And I'm sorry I'm writing over the top of this. I just don't know how to get rid of it. But anyway, so opposite over hypotenuse, so this is going to be 10 over B, is equal to opposite over hypotenuse, which is 0.8660. And again, you cross multiply by throwing this over 1. So this times this equals that times that. So you should have I'm just going to do it. You're going to wind up doing 10 divided by 0.8660, and that's going to give you 11.547. So this is going to be equal to 11.547. And now what I want you guys to take a look at is, does my triangle make sense? So in other words, if this is 60 degrees, you should know that this is 30 degrees. And opposite the shortest, the smallest angle should be the smallest side. Opposite the medium angle should be the medium side. Opposite the largest angle should be the largest side. So when you're doing these problems, those are the kinds of things I want you to think about. Okay? Hold on, I'll be right back. We're going on to the next one. Okay, so I decided to go to the 23-degree reference angle because that was one of the homework problems. So everybody should go and find their 23-degree reference angle because everybody should probably have copies of it. And you should check your answers to see if your opposite over your hypotenuse, that ratio was close to that 3.907. And then to see if your adjacent over your hypotenuse was 0.09205, and then if your opposite over your adjacent turned out to equal this. That's what you want to find out. If you were close, that's fantastic. So again, I want to go ahead and use that to find out and solve this problem to find out what W and K are. And again, I know what these ratios are, so these ratios are going to come in handy for what it is that I need to do. So for example, if I want to find out what W is equal to, I want to look at what side I was actually given. And if you look at this side right over here, this is the hypotenuse. So I was given the hypotenuse, and since I want to find W first, the next thing you need to ask yourself is, who is W in relation to the 23-degree reference angle? That's what you want to know. And you should all be, oh, it's the opposite. So now you're looking at the opposite and the hypotenuse. So of these three ratios, which one are you going to use? You got it. You're going to use opposite and hypotenuse. So opposite over hypotenuse equals opposite over hypotenuse. So now, opposite over hypotenuse, we're going to do W over 18 is equal to opposite over hypotenuse, which is 0.3907. So if I just throw this over 1 and cross multiply, it turns out that W is just going to equal 18 times 0.3907. Whoops, 18 times, I just hit a different number, 0.3907, and that should come out to equal 7.0326. So this is 7.0326. Now, again, we're going to see what we can do to find K. So if I look at K in relation to the 23-degree angle, you should all recognize that it's adjacent. So now you are given that this was 18, which is your hypotenuse, and this is the adjacent. So now you need to say to yourself, okay, adjacent over hypotenuse, I'm going to use this guy right over here. So adjacent over hypotenuse is equal to adjacent over hypotenuse. So, oh, my pen, oops, adjacent over hypotenuse equals, come on, adjacent over, I think it's dying on me, my pen is dying, divided by hypotenuse. Okay, so I'm going to pause and be right back and charge this for a moment. I'll be right back. Okay, oops, all right, here I am, I'm back. All right. So, oh, my pen is going absolutely wild. Anyway, so we're doing adjacent over hypotenuse equals adjacent over hypotenuse. So we're going to do K over 18 equals 0.0295. So K over 18 is equal to 0.9205. So again, throw it over 1, cross multiply, and you're literally going to get K by doing 18 times 0.9205. And that should give you 16.569. So this is 16.569. And again, you should look at your answers and say, do they make sense? If this is a 23-degree angle, you should recognize that this is 67 degrees. So again, opposite the smallest angle should be the smallest side. Opposite the medium angle should be the medium side. Opposite the largest angle should be the largest side. And again, another thing to remember is that if you want to create a triangle, the sum of any two has to be greater than the third. So if you add these two sides together, they are definitely greater than 18 because they're just a little bit over 23. Okay? Now I want to take you through and do an actual problem where you actually do a little application. Okay. So let's take a look at this problem right over here. And you have a right triangle, you have this tower, and you're trying to find out what the distance is between these two guys on your tower. Now, if you look over here, you notice that you have a 25-degree reference angle for actually this triangle right here, and then you have a 40-degree reference angle for that big guy right over there. And you'll notice that the distance from here to here is 87, which is cool. So you'll notice over here, I gave you the ratios for your reference angles for each one of those, okay? So you'll have them on you when you need to do what it is that you need to do. So again, a couple of things that you need to think about, okay? A couple of things that you need to think about. And one of them is like, how am I going to get this length? Well, I hope you see that you're going to get it by finding the length of this. I'm sorry, I'm doing it on such a diagonal, and then the length of that. So I'm going to call this F, and I'm going to call this guy K, because I see that I have two right triangles. One is inside the other one, and I know that I have this length right here is 87 feet. So in relation to, so let's start with the 25-degree angle. So I want to find out what K is equal to. So if I look at my 25 degrees, I know that my 25 degrees corresponds to this bottom triangle. And I know that this guy is the opposite side, right? And so this is opposite. And then I know that this guy is my adjacent side. So I'm going to find K because I'm going to use the ratio of opposite over adjacent. Okay, and we're going to go opposite over adjacent is equal to opposite over adjacent. So we're going to do K over 87 is equal to, and then I'm going to come over here to my reference angle for 25 degrees, and my opposite over adjacent is this guy right here. So it's going to be equal to 0.4660. So as I said to you before, throw it over 1 and cross multiply. So you guys can do that. You can hit pause and do your thing. And I'm just going to do 87 times 0.4660, and that's going to be 40.542. So it's going to be 40.542. So that's K. So that's the distance from here to here. Okay? Now the next one I want to find is F. And now with F, I'm going to use the fact that I have this big giant triangle here, this big guy right here, and my reference angle for the whole triangle is 40 degrees. And again, I'm looking for the side that's opposite, and the adjacent side is still 87 feet. So again, I have opposite and I have adjacent. So I'm going to do my ratio of F over 87 is equal to opposite over adjacent this time for the 40-degree reference angle, which is 0.8391. Again, I throw it over 1, I cross multiply, and I get 87 times 0.8391. And I get 73.0017. So it's 73.0017. So this whole thing is 73.0017. And this guy right here is 40.542. So therefore, X is going to be equal to the difference of those. So that minus 40.542 is going to be equal to, X is going to be equal to, hold on a second, is 32.4597. Oh, I think I have time for one more. Okay, so let's say that you want to find the length from E to C. You want to go from this point all the way down to that point. So there's a couple of things you need to take into account. Right now, you should recognize that ABDC is a rectangle. So if this is 200, well, whoops. If that's too high, there we go, everything's coming back to life, then this is also 200 right over here. Now the interesting thing is we are on the hunt for this guy over here, so I'm going to call him X, and I'm going to call him Y. So if I want to find out what EC is equal to, I have to find out what X and Y are, and I simply have to add them. So if I'm going to do that, again, I have to look at the parts that I'm given in relation to my reference angles, and you'll notice that my reference angles are over here. So for my 34 degrees, I have the opposite, and then this again is my adjacent. And then so if I want to find out what X is equal to, it's going to be, if you want to pause and do this yourself, I think that would be spectacular. So why don't you guys try to do this problem yourselves and then watch back, okay? All right, so anyway, I'm going to keep going. So it's going to be X over 200 is equal to opposite over adjacent. So I'm going to go over to my 34-degree reference angle, and the opposite over adjacent is this guy. So it's going to be 0.6745. And then to get my Y, again, this is an opposite and that's an adjacent again. So I'm going to have Y over 200 is going to be equal to, so now my opposite over adjacent for my reference angle for 62 degrees is this guy right here. So it's going to be 1.8807. So if I multiply these out, I get X is equal to 200 times 0.6745, which is 134.9. So this is 134.9. And then 200 times 1.8807, and that's 376, so I'm going to add that to plus 376.14, and you're going to add those two together to get the length of that whole thing. Now what I want you guys to do is I want you to really think about Am I going to have to do this every time, or is there a faster way, or is there something you can do on your calculators yourselves? And the answer is yes, you can, and you're going to find out on Friday. But what I want you to do is go onto that calendar and keep working on the problems that I assign for you. Good luck.